Welcome to this Eclipse tutorial series. My name is Michael Traeger, and I created these videos while finishing my master's degree at Duke University. This tutorial series was funded by the Medical Physics graduate program at Duke University. These tutorials will be focused on providing an introduction for students in the Duke Medical Physics graduate program with respect to a project they will complete during their radiation therapy class, but can be extended as a useful tool for any beginner Eclipse users. As a disclaimer, these videos are not meant for use as guides for clinical applications, including treatment planning on real patients, rather as a good starting point to familiarize new Eclipse users. I'm not affiliated with Varian Medical Systems or with the ARIA software at this time, and am by no means an expert user. In this video series, I will cover the basics of the Eclipse interface, getting started with the treatment plan, contouring strategies, basic 3D planning, IMRT planning, and how to analyze plans. I'll be working with Eclipse version 13.6 and ARIA version 13.6. Alright, let's get started. This is the third video of the Eclipse tutorial series, Contouring. In this video, I will discuss the selection, registration, and contouring features of Eclipse. Specifically, I will talk about what the selection feature does, how to register images, navigating the contouring workspace, creating a new contour, contouring tools, some basic strategies, the importance of the body contour, and how to create and modify it, how to override Hounsfield units, and how to create your own virtual phantom. Let's start in the external beam planning window. For this tutorial, we will use the abdominal phantom that we loaded in the last video. From the external beam planning window, we can access other planning functionality through the workspace bar that we previously discussed, up here on top. First, let's choose the selection window. Here, we can select a subset of CT slices to use from a full CT. For instance, if you do not need the whole simulation CT set, you can trim it down here. But for the purposes of this video, we'll use the whole CT set. Now let's click on the Registration tab. Let's learn how to register two images. Registration is useful for aligning two images that were not taken in the same position. For example, if there was an offset between two images, we can register them so that they are aligned and we can therefore compare them and transfer contours correctly. Another use of registration is aligning images from different imaging modalities. We want to register them so that we can use them both for planning. For example, for prostate cases, we often register an MRI and a CT. This allows us to delineate the PTV, which is the prostate, on the MRI since the MRI has much better soft tissue contrast. Then we can transfer that contour onto the CT image. If these images were not registered, however, we would not be able to do so because the contour would not be in the correct location and would therefore defeat the purpose of contouring on the MRI in the first place. This is also useful if we want to simply transfer contours from one CT to another. They must be registered before we can transfer contours. In the image registration workspace, we have our transverse, sagittal, and frontal views. We also have all of the CTs that are associated with this patient. To register images, we can right-click on one of the CT scans and select one of the options. So we have auto matching, manual matching, and point matching. For now, we'll select manual match. Once we select that, we can do a name for our registration, so we'll just leave it as registration for now. And then we have a source and a target image. The target image is the image that we are registering the source to. So for now, it doesn't matter for us. So we'll select OK. And this will start our registration. We now have both images superimposed on each other. As you can see at the bottom, we have a slider bar. So as we slide this from the left to the right, we can see our source and our target image in different intensities. Bony structures are the best to register to since they're rigid and will not change between scans. However, if we're only interested in an area of soft tissue and are doing a registration on the day of the treatment to align a patient, we should be careful about this. It really depends on the current situation for which you are registering images. For now, let's align to the bony structures. So we can click and hold and then drag the image to move it, but we can also use the arrow keys, and this does a finer adjustment. We can also rotate the image by selecting outside of the circle that you see in red. So we can move the image in all three planes. It's important to look at all three views when doing registration because although the images look registered in one view, they may not be aligned in another view. So let's try to align it right now. You can also scroll through the images to see different slices and see how aligned you are. To switch the views that are large, we can select this little rotate button, and this will toggle between views. Once we get the images close, we can use an auto registration to further tweak our registration. So we'll once again right click on the CT and select auto matching. This often doesn't work unless we give the system a good starting point, especially when there's more complex anatomy than this phantom here. So we can select a region of interest. We'll focus on one area for now, and you could do this volumetrically. So we'll consider all the axes and rotations. So we'll select start. You can also specify an intensity range. And a structure volume of interest. So now we have our registration. We can now save the registration. And we'll see now we have this line under these two CTs. So this line indicates that these two CTs are registered together. So now that our images are registered, let's go to the contouring window and learn about contouring. Now that we're in the contouring window, let's discuss what we see. So as in the external beam planning and the image registration windows, we have our three views. We can scroll through the slices with the scroll wheel on the mouse, as well as using these slider bars. We can zoom in using Control and the scroll wheel on the menu on the mouse. We can maximize the screen with the Maximize button. We can rotate through views with the Rotate button. What's different, however, is on the left side, we now have a list of all of our structures. For now, we only have the body. And on the right, we have a whole list of contouring tools. So to load a CT, we can double-click on the CT, and then all of the associated contours will be pulled up. We can check or uncheck boxes for the structures, and that will show the structures or hide them. Let's recenter our image by right-clicking on the body and selecting Move Viewing Planes to Structure. Now that we're centered, let's create a structure. So to do so, you can click on the Structure drop-down and select New Structure. We will then be prompted to select a label. This is used to identify what type of structure this is going to be. So for now, let's choose PTV, high risk. So we could also choose an ID, so we'll just choose PTV. The type is PTV. And now we'll choose a color. So let's leave it as red. Select Create, and now we have our first structure. So as you can see, it pops up on the left side. When a structure is created, it starts out blank. So we have to use the tools on the right-hand side to actually create our structure. Another way we could have created a structure is to right-click on CT and select New Structure. So now that we have our structure, let's discuss the various tools on the right side of the screen. So to use a tool on a structure, first we can select the structure. So we'll click on PTV. As you can see now, all of the tools are able to be clicked on. The first tool we have is called Draw Planar Contour. What is nice about these contours is we can select to have interpolation in empty slices by selecting the automatic interpolation box. This allows us to skip planes when we draw contours and allows the software to interpolate in order to create a 3D volume. We can also extrapolate, which suggests an identical contour in the neighboring slices to help expedite your contouring. Next up, we have the Brush tool. This gives us a circular cursor in which we can paint a contour, as you can see here. We can choose to do this in a slice-by-slice fashion with our 2D mode enabled, or we can select 3D mode, which allows us to create a spherical volume. We can define the size of our circle or sphere, and even structures to overlap, or avoid overlapping. So as you can see, if I start drawing with this here, it'll create a 3D volume, so you can see it in all of the planes. One nice thing about contouring is you can simply select Ctrl-Z if you want to undo a contour that you've done. So next up we have the eraser. The eraser has the same exact functionality as the brush, however it will erase the contour that you're overlapping with. Our next feature allows us to draw shapes. So we can draw either a rectangle or an ellipse shape by dragging our mouse on the image. So this will only do it in a 2D fashion. So let's go ahead and erase that. Next tool is Create or Edit Annotations. With this tool, we can make text annotations and they'll show up on our image. So this is good for labeling various things. The next feature lets us draw a 3D contour by drawing 2 or 3 orthogonal contours in each view. Then we have the transform structures. So this tool is very useful. Here we can change the size, location, or even rotate structures by selecting them. The last drawing type tool is the deformation tool. We can choose the size of our cursor and then drag edges of the contour to create unique shapes. So let's make a structure. So we'll draw with the brush in 2D. So here we can simply push the edge of the structure and drag it to make a new shape. Transforming it, we can move it as I mentioned and rotate it. Also change the size. Next we have some tools that don't require drawing. So the first one is the image thresholding tool. This allows us to choose a range of Hounsfield units to assign to a structure of our choice. This can be very useful when contouring the lungs or bones. We can also select a region of interest when doing so in order to limit our thresholding to a certain volume. Next we have the search body tool. This tool is similar to the image thresholding tool, however it uses only a lower Hounsfield unit threshold, and this allows us to create a structure. Next up we have the segmentation wizard. So this uses predefined Eclipse functions to search for a specific organ. This will assign all voxels that it deems as a part of the organ to the structure of your choice. Once again, we can choose a volume of interest for this tool. Next up we have the flood fill feature. This feature works like the MS Paint flood fill feature if you're familiar with that. You can specify 2D or 3D and click on a region to fill with a certain structure based on the Hounsfield units of the initial click. The next tool is very useful. Here we can create a margin from a specific organ to save as a new organ. We can choose a symmetric margin, or if there's an asymmetric margin, as well as an inner or outer margin. This is very useful when creating a CTV from a GTV, a PTV from a CTV or ITV, and many other scenarios. So I'll quickly show you how this works. So let's create a circle. Oh, but we got to select our PTV first, so that was on our body. So we'll draw a circle, go to our margin, so we'll create a margin from our PTV. Our target is the PTV, so we're pretty much just expanding this. We'll use a symmetric margin of 1 centimeter and apply. So as you can see, we have a 1 centimeter margin added in all directions. Next up, we have the post-processing tool. This can be used to further customize and perfect your contours. I won't get into this in detail, however. Next we have extract wall. So this is similar to the margin tool. We can create an inner or an outer wall as well as a combined inner and outer wall. Next we can crop structures, which is pretty straightforward. Then we have the Boolean tool. This tool is very useful. Let's make a bladder contour to demonstrate how the Boolean tool works. So all of these labels have presets that go along with them. So if you select bladder, it names it for you, chooses an organ, and selects a color yellow. So we'll leave that. So let's draw in a bladder. And so here's when the Boolean comes in handy. So with this tool, we can choose structures from our list of structures, along with various Boolean operators to create a new structure or morph the original structure. So we can make a composite PTV of 2 or more individual PTVs. We can eliminate overlapping parts of structures. We can subtract one structure from another, and any combination of these. Becoming familiar with the Boolean operators allows you to efficiently create complex structures. So for an example, let's get rid of the overlapping parts of these 2 structures. So we'll subtract out where the bladder is from the PTV. So we can select PTV minus the bladder. So we'll get rid of this overlapping part. We'll select the target structure to be the PTV and select apply. So as you can see, we now reduce the size of the PTV to not cover the bladder. The next tool is the Extend Segmentation tool. This tool allows us to extend a contour into the previous or next plane along the same path that the contour was directed. We can choose to extend the contour one slice at a time or continually until we choose to stop it with these buttons here. So let's say we have our PTV, we want to extend it one slice up, we can select Extend. Could also do the same going downwards. So we can move our slices to the bottom and extend it downwards. Next tool is the Interpolate tool. So this is useful if we have a couple of areas where we have contoured and we want to interpolate all the voxels in between. You can also choose Extrapolation. Next up, we have Segment High Density Artifacts. So this tool helps you get rid of artifacts that come from high density regions, such as dental implants. And this last tool gives us the ability to clear a structure from the current or all planes. So our PTV, let's clear it from all the planes for now. You could do the same thing by right-clicking on the structure. So let's clear the bladder. Clear structure from all planes. As I mentioned before, we can right-click on the body or any structure and move our views to the target structure. So let's go to the center of the body. To add an isocenter, we can right-click on the image and select New Isocenter Marker. So this will allow us to choose coordinates of the isocenter. They're currently set to wherever our planes are intersecting. So let's put an isocenter there. Once we have our isocenter, we have an option to move a marker or isocenter marker. So our current isocenter is here. Let's move it a little bit. The next option is to edit a reference point. However, we don't have any reference points, so we can't do that right now. And lastly, we can draw reference lines, which allows us to track dose. But we don't have any reference points, so once again, we can't do that. The last tool we have is the ability to detect Calypso beacons. Calypso beacons are 3 seeds implanted into the prostate or other organs that allow you to triangulate an RF signal for live treatment motion managing. So we've discussed a lot of tools. I would mainly focus on the planar contours, the brush, the thresholding, margin, and Boolean tools when you're getting started because I find that these are the most useful and most straightforward. You can continually add more tools to your contouring as you get more advanced. Let's draw our prostate contour, our PTV, so that we can discuss some contouring strategies. So I'll use the planar contour tool. And we have automatic interpolation on, so we can skip some slices while doing this. For now, this is fine. One useful strategy is to use the Convert to High Resolution Segments tool. To use this, we can right-click on a structure and select Convert to High Resolution Segment. So this now says the structure was transformed into a high-resolution segment. This is important for small structures where the exact location is very important. After converting a structure to a high-resolution segment, everything calculates to a finer resolution. For example, the edge of the contour, the dose, and other things. Another useful tool comes up when you click on a structure with the cursor option selected, or the Select Structures. So if we right-click, we can now see a bunch of options. So these are all the tools on the right. It's just quicker to see them. So we can draw a planar contour, we can erase, we can transform the structure, and various other options. One thing to keep in mind is that if a structure has already had dose calculated on it, or if a structure is approved, you will not be able to modify it. Now let's discuss a little bit about the body contour. The body contour is very important. This is the structure that will be used during inverse optimization as a normal tissue objective, which helps us limit the dose to all non-contoured healthy tissues. Also, the body contour can be used along with Boolean logic to ensure that structures are within the body. The body contour is typically automatically created. However, if it's not created, a useful tool to create it is the lower threshold tool. It is important that the body contour is used for Eclipse to know where to calculate dose. So all immobilization or couch structures outside of the body contour will not be accounted for. This is useful to discount the couch from your calculations, but can also complicate things if it's there during the treatment. To modify the body contour, you can select it from the contours on the left side of the screen and then use any of the tools we have previously discussed. Something else you should know how to do is how to override Hounsfield units. So to override Hounsfield units, you can right-click on the structure and select Properties. You can now go to the CT Value and Material tab and select Assign CT Value. So we have our prostate selected, so let's make this bone. So as you can see, our prostate now looks like bone. To undo this, we can go back into Properties and uncheck this box. The last thing I will discuss how to do in this video is how to create a phantom from scratch. So to do so, you can go to the Structure dropdown and select New Phantom Image. So now we'll be able to select the dimensions and the material, or Hounsfield units, for the phantom. So let's create a cylinder, have 6 cm in the X direction, 6 cm in the Y direction, 10 cm in the Z direction. We can choose the slice thickness, so let's choose 1/4 centimeter, orientation, and assign a CT value. So this phantom will be put into the current patient that's open. So as you can see, it was added here. Thank you for watching this video in the Eclipse tutorial series. I hope you now understand how to register images and how to contour effectively. My next video will teach you how to create your own 3D conformal treatment plan, as well as help you to better understand normalization. Thank you, and I'll see you next time.